Yeah, hi everyone. In this video, we will talk about coding circuit using scrolling register. Coding circuit means channel coding circuit. So far, we saw how we calculate, right? So we took a paper and pen and we did this division and all by ourselves. But how actually will be done in computer? It will be everything. All the computation will happen in terms of circuit. And this encoding circuit, how it can be implemented and the necessary code word gets generated for the given data word is what we're going to discuss in this. So that's about the coding circuit. And it's using scrolling register. Scrolling register can also be called as shift register. So you all might be knowing about a register. Register is nothing but the storage. It is the fastest storage available on computer. So we can use this register for storing bit temporary. This is a temporary storage, we can say. And we use this shift register for constituting or creating a circuit, and that actually will perform the code word generation. So when you give the data word, okay, so the data word will go through this particular entire circuit, and at the end, a code word gets generated, and that is kept on the channel. So this is the channel which will be propagating the data to the receiving side, and we keep the code word onto the channel. So we generate the code word. So far we just did the division, some calculation, but how does that happens on computer exactly? So this is how the circuit we use for that. And this circuit will be using multiple components. Let's decode one by one. So you totally have three registers here. Not three. Generally, there are so many registers, like these are the R0, R1, it goes up to Rn. So registers you have. And this is the data word. Always we use U to represent the data word, right? So data word is given as input and we get output is EX. That's nothing but the code word. Okay. If in case like yours is data word 7, 4, 1 in terms of BCH. Okay. So there will be 4-bit data word and a 7-bit code word getting generated with this particular coding circuit. And you also have something called G1, Z0, Z1 up to Zn minus K minus 1. So these are the polynomial coefficients. Okay, for example, like for generating code word, we use a polynomial generator that is g of x is equal to x cubed plus x plus 1 according to BCH. I'm not just randomly writing something, it is already there in the table. So if you see in the table for generating code word with 7, 4, 1, we use 1, 3, which is an octal representation. And when you convert that to a binary and write a polynomial representation, you get this. Okay. And in here, if you see, this equation can also be written as 1 dot x to the power 3 plus 0 dot x to the power 2, because it is not there because the coefficient is 0, and then 1 dot x and 1 dot 1 or x to the power 0, something like that. So this is x to the power 0, x to the power 1, 2, and 3. And yes, so these are the inputs you will be giving. So whenever there is 0, it is open, means there is no any connectivity. And whenever it is 0, then it is closed. So there will be a connectivity, and that leads to some XOR operation. Yes, it might be a little difficult to understand. Yes, when we do a small calculation here, you will come to know what exactly is this. Okay, so the G0, G1, G2 up to Gn minus K minus 1 is the coefficients of the polynomial generator. If it is 1, then it is closed, means there is a connection. If it is 0, then it is open. Then it means then there is no any connection for the XOR calculation. Just that's the thing. And you have registers like R0, R1, and Rn. So multiple registers will be there, and you have a data input. And the input will be directly placed on the channel as well as it goes to the circuit for calculation. And what exactly it does, it will calculate the remainder. So when you go for dividing a dividend with a divisor, you will be getting a reminder, right? So the same reminder is what we are also going to get it in here as well. Just let me try to connect my whiteboard. It's not connected. what happened? Yes. Yeah. Yes. So this is how the circuit will be understood. So now we are just going to our specific use case, like we created a code word, right? So the same code word, let me take for the polynomial function, that is g of x is equal to x cube plus x plus 1. This is the polynomial generator polynomial for the code word, that is BCH. And then the data word, what I'm going to take for an example here is 1101. So data word is 1101. And we are performing a code word calculation according to BCH. Okay. And one more thing, like if you see here, the data word is given to this particular circuit. So this is little customized circuit when compared to the generalized one here. And if you see here, we totally have 3 coefficients only, but I just have only 2 closed connections. This is an exclusive OR operation. I just only have 2 closed connections. The last one is not there because of this particular calculation. So if you say G of n minus k minus 1, so in ours, this code is 7, 4, 1. 7 code word for input data word, right? So that is 7 minus 4 minus 1. So you end up getting 2. So that is why only we have 2 closed connections, not more than that. So that is a calculation. So we go and have only 2 closed connections here. So this will represent Z0 and this will represent G1, and that's it. So we don't have G2 because there is nothing. Okay. That's how you have to generate it here. And it purely depends upon the number of code word what you're going to generate as a parity bit. See, data word will be of 4-bit and you will be generating 3-bit code parity. All put together will be giving us a code word, right? So it depends upon this. Okay, fine. Now, one more thing, if you take this particular data word, so data word, when it is going to the circuit, will be going in this order. So D0 will go first, D1, second, D2, and D3. So it means, so data will enter this circuit in this order. Okay. So first bit will be 1, second 1, 0, and 1. So something like that. So it will go inside the circuit. And if you see the circuit, the data word, whatever is going to the circuit, will be also going to the channel as well. So this is the channel. So channel will be getting the data word. So first bit is 1. So when this 1 is getting inside the circuit, it also goes to the channel as well. Yeah. So when the data word is given, 1, it enters the circuit, and the same will be also kept on the channel as well. And the 1 goes here, and you also have, as I said, R0, R1, R2. So totally here we will be having 3 register only, namely R0, R1, and R2. Okay, so before proceeding, I need to write a table. Let me just empty some space here and write the table. The table should have the input bit R0, R1, and R2. So these are the registers we have. Initially, when there is no any input bit given, we set this register to 0. Initial value of all the 3 registers. So every register is capable of storing 1 bit of information. Just imagine that way. And initially it will be set to 0. When input 1 is entering the circuit, okay, the calculation will start. So when 1 goes here, okay, 1 is here, and the direction, the flow of data will be like this. Okay, so now 1 gets exclusive OR operation performed with OR. R2. What is R2? It is set to 0. So 0 and 1. So 0 and 1. So you know in exclusive OR it is 1. So it means that will be given as input for G1 circuit and this Z0 as well. So these two will be 1 and 1. Okay. So now we have to perform the next bits in this registers. So when this is happening, so there will be shift operation also will be happening alongside. So that's why it is called a shift register. So on every clock pulse, the data will be keep on moving towards right. So R0 data will move to R1 data will move to R2. So previous R1 is 0, so that comes to R2 here. Next, R1 also will be getting a modified data, but for R1, what is the previous? So if you see the calculation here, R0 exclusive OR with G1. So G1 is 1. R0 previously it was 0. So 0 and 1 exclusive OR will become 1. So that is why R1 will become 1 here. I repeat, the R0 value previously was 0. That gets exclusive OR with 1. So you get 1. R1 is 1. Now if you see, you are pushing a new value inside R0, that is also 1. And this is a new value for R0, R1 and R2. And this will continue until you have input in the data. So next is again 1, and this 1 will be channeled through this particular circuit. So now we are going and putting that 1 also in the channel as well, and it is getting inside this circuit also. So what is current R2 is 0, and current input bit is 1. So 1 and 0, it is still 1. So it is 1 and 1, which is taken here. Next, let's perform. So the new R2 value will be straight away R1. What was the previous R1 will become the current R2 for the input bit 1. So now R2 will become 1. Fine. R1 gets calculated using some exclusive OR operation. What is the previous or not value? That is 1. Now here in the current input, it is 1. So 1 and 1, it becomes 0. So R1 becomes 0. Next, or not. So you are giving input as 1. So or not will become 1. So this is the current value for or not, R1 and R2. Okay, so second bit is processed. Now let's go with the third bit. So that is going to be 0. What's happening? My system is a little slow, I hope. Let me pause and set it correct and come back. So the next input word is 0, and that goes here. That will be kept on the channel. And the same will be given as here as well. Now, what is the current R2 value? It is 1. Let me route this. So R2 is 1. So 1, 0. Again, it's 1. So 1 and 1. Never this value got changed so far. Every time it was 1. Now, the current R2 value will be the previous R1. It was 0. So that 0 comes here. Next, R1 will be calculated as previous value of R0, that was 1. And the value of G1, that's also 1. So 1 and 1, 1 exclusive R1 becomes 0. And then the new value for R0 is 1. So when the input is 0, this is what the modification will take place for these three registers. Next input bit, the last one is 1. So when 1 is entering, so 1 is taken. Okay. And let me modify this as well. Something is happening. My system is not behaving as expected. Yeah, let me write it here. So when 0 goes here, so previous value of R2 is also 0. So 0 and 0, it becomes 0. So this is 0 and 0. Okay. Now R2, previous R1 is R2, that's 0. Now R1 will be calculated as previous or not value, that's 1.